Okay, so hello everyone. We are back again with our next class related to the BootCamp 2021. Sasya, do you want to add anything?
No, not right now. Maybe from the next class.
Okay. Okay, so
I think live streaming is started.
Yes, it is started.
Yes, it is started. And you have started recording?
Yes, it is recording. Yes, it is
Thank
being
you.
recorded. Okay, so let me first share my screen and then we'll move from it. Okay, so in last class we had discussed the chapter 2 of the mastering blockchain Ethereum blockchain programming with Solidity. So we have covered most of the chapter, but 2 points were remain. So I'll cover those 2 points today, and then we'll move towards the chapter 3 of this book, and we'll progress with this. So in last class, at the start of the class, of the very few topic we were discussed was related to the call and call delegate. So anyone can tell me or the repeat what we have discussed about the call and call delegates. No. Okay. So the what we were discussing is that the address data type has few functions called call delegate, static call, and we have discussed them in detail. The difference between the call and call delegate was that when we call a function with the call delegate, it is being called as a normal call like we do in this way. When we call create a contract and call a function with the dot operator, so it is being called like we are calling a function from another contract, and whatever happened in that function will be assumed that it is part of second contract. But if we wanted to call a function that behave like it is a function of a current contract, the contract which is calling that function. So for that, what we do is we call the call delegate function. When we call a function of any contract with the call delegate, so that function of a particular separate contract become part of this contract which is calling that contract, and in the context remains the current contract. And the static call was related to when you call a contract function with the static call, it does not change the state of a function. So if your that function is being trying to update a state, then you will not use the static call. So the point which will remain in this topic is when we these are the function of a contract. When we have a library by default behave like this delegate contract. So if we have a function in a library and we use library in our contract, so library function is exactly behaving like we are using the call delegate. So we need to see how this works generally. We have already seen how library works. So what I'll do is I'll create a library. And we will have a function in it just to show that it will behave exactly like same. I'm just copying the exact same function from the contract. Just ignore the value. Now in library, we needs to have a function as internal, because if we make it a public, then the problem is we need to specify the library separately from the contract, and we have seen in 2 or 3 class back that we have to specify pass the library separately. Generally, when we create a library, what we wanted to do is we wanted to call that library inside the contract. So we generally make them the functions of library as internal. So when we call that function inside our contract, it behaves like they are function of a current contract. So here, if we see the message.sender, like we have seen in second contract, the message.sender and text.origin. In case of call, message.sender will be the caller demo class contract. But in case of delegate call, it will be the function. It will be the address which initiated the call of this caller test function. So what we have wanted to do is we wanted to call now this function from here. And here in library, what we'll do is we will call, first we have to import the library info. Okay, so we don't have to do anything else, just the call of a library function. Now, what we'll do is from the script, we'll create the instance of this call function, the contract of this call function demo, and then we'll call the function caller function test library. What it will do is it will send the request to a function of a library. In general, what we have seen previously, the call delegate, it is being called for a contract, but it behaves like it is function of a current contract, and all the message sender and everything will exactly like they are being running here. So what I'll do is for the script, we have already seen this, so I'll copy this script and this here, and we'll keep these at this moment we don't need them, so I'll keep them as it is. I'll just change these. It is just creating the contract, second contract, creating the caller function contract. And then we'll call the okay, so okay, compilation is done. Actually, I haven't changed the call. call demo function, which okay, we are calling incorrect deployment script. It should be deploy 3. Okay, so the contract is being deployed. The difference is we'll see here that we got 3 console calls. And let's go back to the library. What it says is just trying to print message.sender, transaction.origin. Message.sender is the one who send the call to this function. Generally, when we normally do uh, call of a contract like this, that means the caller is this contract. So message.sender should be this contract, and the transaction.origin should be the one who initiate the transaction. And address of a current contract, that means address of this contract. In case at this moment it is a library. If it was a contract, then it should be the contract address. But because we are calling it from the library, so you see we have message.sender is 2266, transaction.origin is 2266. What they are, it is the externally on account, the one who initiate the transaction. So we have initiated the transaction from here. So this owner or current caller is calling this function, caller function test library. The request go to here, and it tries to call the library. So whenever we call the function of a library, it works exactly like that. This function is being called inside this current contract. And if you see the address of a current address, what is the address of this? It should be the address of current. If this function was inside contract, it should be the contract address. But what we are receiving is 75707. 75707 is the address of a caller demo contract. We have seen all these things in detail in our previous class, but the only thing which was missed is we have not seen from the context of library. Otherwise we have seen all those things. As we, let me just show again. If we do this with the call in the second contract, message or sender, origin and value. So instead of this function, if I call now, if we see that message or sender is 2EBE6. Who is 2EBE6? It is actually the caller demo contract, 2EBE6. So what it means is when we try to call function from the external world and say from the caller demo function, that call a function, it send request over here, and that request goes to the second contract function. But because it is a general standard call which can be called like this as well, so it will behave like it is a separate contract. And the separate contract is means message or sender will be this caller demo. Transaction dot origin is the one who initiate the transaction. Address of a current, which is 5C835. So address of a current is 535, means address of a second contract 5C853. So it is being called, it is like we have calling a contract and we are sending a request to a function, which is like generally we do. But when we do the delegate call, which we have seen in our previous class, so it will behave like this function is being part of the current contract, and all the message or sender and this will be related to this call function, and library will do exactly the same. This is the same we do with the library, but for library we do not have to use this kind of low level call. these call low level functionalities on the address level. So we are calling the delegate call. For contract, we will do this. If it is a library, we don't have to do this. It will normally behave like it is a part of current contract. And we have covered all these things in detail in our previous class. Just the library one was missing. Any question till here? So I'll move to the next part.
Zishan, before we move forward, I just like to add something.
Yes.
Zishan, can you hear me?
Yes. Yes, I can hear you.
I just remembered that on next Saturday, I will be in Faisalabad and all of us will be in Faisalabad. So therefore, we will not have a class, at least the English class next Saturday.
Okay. Okay.
And please remind, before the end of the class, remind everyone that in the next class, in next Saturday, the English class at least will not happen.
Okay. Okay. I'll be updated up at the end of the class.
Go ahead, please.
Okay. So as this is done, the last topic for the chapter 2 is the ABI encode functions, which we have seen a bit, which we have seen in our previous example as well. The ABI.encode with selector. We have seen ABI encode with signature as well. Selector and signature. We have seen these functions. So yes, ABI encode with signature. So we have discussed all these functions, but what the output these functions give us, we'll see over here. So we have 4 functions: ABI.encode, ABI.encode, encode packed, ABI.encode with selector, ABI.encode with signature. So basically, what they do is they give us an output in byte format. So generally, when we try to do a low level calls to the assemblies, or we are doing over here, the contract.call, and we wanted to send this message signature and the parameter as a message call, it will be like we are passing the data to a function call. So all the inside, for us, it is like dot operator abc dot do something, but for internal, for the actual Solidity calls which go to the EVM, it does that EVM does not know what the second contract is. EVM does not know what do something is. It actually knows the signature of a message which is in byte format, the value of the parameter which is in byte format. So low level, at the lower level, all the calls in the byte data. So we are sending actually the byte data. So when we wanted to do the low level call, we use this ABI.encode and all those things, and we have seen them all in detail. The only thing we will see that what they generate, what is the packed, why they are adding the zeros into the in front of the all the values. So that's what we need to see. And for that, actually, we have in step 4a, we already have this ABI encode example from this same chapter. So I'll just copy this and I'll explain these functionalities so that we understand what they are and why and when we be using them. Okay, so basically, whenever we wanted to send a low level call to a contract, so we are actually sending the data to the blockchain, and the blockchain tries to call that function or the contract using that information. For that, at the lower level, we cannot specify that this is the in 15, in 16, it is in 24, and this in 32, and you just have to identify. So there will be a lot of variables, and there are a lot of checks needs to be involved to separate out the values. So what they do is, when you call the ABI.encode and you pass as many as parameter into by separating with the comma, so what they do is it converts it into the byte 32 format, and if the parameter you have passed is smaller than the byte 32 values, it adds the 0 as a padding. So you see the address parameter, which is this one, 0x 2D65. This is the address value. But to make it byte 30 type of byte 32, it adds these zeros so that it will all the parameters will remain at the same size. So when go to the EVM just know that I have to separate the parameters at the byte 32. So it will not have to identify that either whether I have received address or I have received in 32 or I have received in 36. Whatever I have received, I just have to uh, break the parameters based on the values I have received and just break on byte 32. So if you see the int uint, which is uint 256, it has a value 20, and all these values are in hexadecimal. So you see it has added all the padded zeros over here. Again, uint 8, all the padded zeros over here. Uint 16, all the padded zeros over here. Let me just run it and I'll show you. Okay, so we have created this, and at this moment I will just call this first function encode. What it will do is it will call the abi.encode, and abi.encode will return the bytes array. It is a byte, so it combines all these values and will give you the single bytes. It will have all these parameters concatenated. Okay, so why there is no output? Okay, I just changed the name. Okay, you see this is the complete message, a single message. So whenever we send the call, so the actual call which go to the EVM, it's actually this data. So data is being sent like this, and if I, this is the single value, and what the compiler or what the runtime or what EVM will do, EVM knows that I need to separate it based on 34 bits, 32 bytes. So it will just have two separate values like this. and it will know that what these values are. We do not have to specify that it is in 34, it's byte, or whatever the value is, it is an address or it is a string. The EVM knows how to separate these values. This same thing goes for the function calls as well. That's why we were in last class we were using this message.signature, ABI.encode with signature. So the second one is, then you will see the difference. Encode peg. When you wanted to call a contract or call a function, then the ABI.encode is the one you need to call with. If you wanted to just save the space and you wanted to do the concatenation, it will not be used for the calling the external contract, then what you can do is ABI.encode peg. And we generally, what we do is we, for the concatenation, generally we, for the string concatenation or any concatenation which we wanted to use within our domain or within our protocol or project, then we use generally the ABI.encode peg. Encode peg, what it does is it does not pad the zeros of the parameters to make it complete 32 bytes. You see, this address is this one, so it has not added any padding to this. This is u in 256. So because it is u in 256, so u in 256 should have zeros related to the u in 256. So that's zeros being added. But uint add does not require additional zeros to make it byte 32, size of a 32 bytes. So you see here it was adding these padded zeros. It does not add over here. For uint 16, because values is small, it's adding the 2 zeros over here. So in this way, we generally, when we wanted to concatenate, and I generally use it in for whenever I wanted to concatenate the string, because the string concatenation is not available. So I convert the string into the bytes and then concatenate the string using this function. So we generally do the encode peg for the concatenation, and it will not go for the contracts call or the call for the function call for the EVMs call. It will just for the encoding. And it will also save the space because these padded are not being added. So if I go over here now and okay, now you see this is the address, this is the u in 16, u in 256, then the other two values. So it will be helpful in concatenation, but you cannot send the lower level calls to the function and contract using encoded peg. For that you need encode function. And the other two, encode with selector and encode with signature, they are actually kind of a wrapper on encode. Only difference is they are used for function call. So when you wanted to do a function call, so they ask as a first parameter the name of the function, then the parameters. So that's what we have done in our previous classes. If you see ABI.encode with signature, then we pass the function signature, and the second parameter is what value we wanted to pass. So ABI.encode with signature. So the first parameter, what they do is they convert the first parameter in as a signature of a function, and it will be the byte 4. Other all parameters, it will add the padding zeros on all the parameters. So if we see here, encode with selector, and we are passing the method signature over here. So we have two options. Either we pass the method signature using the word selector. So this dot test method dot selector. So it will become the signature like this. It will the byte 4. It contains the byte 4 bytes. U in 256, it will be the padded with zeros. uint8 will be padded with 0. So you can easily understand that when we send a call to a function in a contract, so EVM does not have to worry about whether it is uint8, whether it is uint256, whether it is an address or what. It just have to break them in the first 4 byte. It will extract, so EVM will know that this is the function I need to call. After the first 4 byte, what it will do is it will break all the byte 32s, and it know that this is the first parameter, this will be the second parameter, and it will pass the parameters, and function get call will be done on the blockchain. Now, if you wanted to do the encode with signature, if you don't want to call like selector, it is available. So it's better to do it yourself. Otherwise, what you can do is you can pass this message method signature in KK56 hash and convert it to the byte 64. So this call is exactly similar to this. We don't have to worry about this all calling all these things, because Solidity provides us directly the selector. So it's better that we call it directly. Other things are similar. These the last one is encode with signature. In encode with signature, what we do is we actually pass this signature, and all the rest of the thing, converting it into the KKC 256 byte 4 is the responsibility of this function. So we'll pass the signature of the function, parameters, and the responsibility of converting into the byte 4 will be the encode with signatures function. Now I'll call these two also. Okay, so you can see here encode with selector. This is the first 4 byte, which represents the method signature. So inside the EVM, there is nothing called test method. It is actually the bytes which represent the signature of a function, and the other 32 bytes for the second parameter and third parameter. This message go to EVM, and then EVM tries to understand and call the function based on this. And this is exactly same with the signature. The only difference is how we call it. So both will work whenever we wanted to. And we have seen both of these examples in our example in our previous class, encode with signature, and there was also encode with selector. Yes, encode with selector. So we have seen both in our previous class in detail. Okay, any question over here? So we can move forward.
Sir, for my understanding, ABI encode is when we put the ABI encode, it combines all the code together. But when it sends to the EVM, then EVM itself distinguishes the whole code. It separates.
Because
Okay.
EVM know where what I have to do. So it's kind of an what you say. It's established fact that all the parameters will be of byte 32. So I just have to break the data based on that. So EVM knows it.
Okay. Only this is the difference.
Yes. Okay, so now let's we are done with this chapter. Let's move to the chapter 3. If else, we have already done evaluation order is generally like any language. What we need to see here is the modifier, also constant. Yes, constant, and one more thing is immutable. Okay, so what I'll do is for this we have step 5b, which does not have any contract at this moment. Now what we need to see is basically there are two constant is generally, as we have seen, constant is a variable which will not change once we assign the value, but there is another variable, another keyword, immutable, which is being introduced maybe after Solidity 6 or 7, which can be initialized once. So we need to see how that works. For that, 256 public amount, public constant amount. Generally when we make the variable constant, so we generally use capitalize. Okay, so if I'll do the without initializing, if I'll try to compile it, it will give me an error at this moment. File import. Okay, let me go to the script and okay, so if you see uninitialized constant variable, constant variable must needs to be initialized. So let me say it's 45. Okay, this is the normal about the constant in any language, so there is nothing different. Just wanted to show. You will not be able to update the constant, because once it is done, you cannot change it. Now the problem is, for the constant, what we have to do is the value should be available at the compile time. But sometimes what happen is we need a variable which should not change, or people cannot change it, or it is not changeable, but initially we need to initialize it at runtime for the very first time, and then it should not be able to change it. For that, the new keyword has been introduced maybe after Solidity 6 or 7. I don't remember exactly the version when it was introduced. What you can do is you will 256 public immutable. Let's say name it value, and I have not initialize it. Now, if I'll try to compile it, it will give me an error that at least you need to initialize at some point of the initialization. Okay, so constructor control flow ends without initializing. So it says constructor is completed, but it has not initialized the immutable variable. So you must need to initialize your immutable variable inside the constructor. So whether we can receive this value from external from out when someone is trying to initialize at this point, or we can provide the hard code value inside the constructor. So once we do this, it will work fine. It's compiled successfully. Now, if I try to change value equals to 45, is it value? Okay. Okay, so we have an error because we cannot update it. So constant needs to be set at the compile time. So you have to initialize it at the time of declaration. You cannot separate the declaration and initialization in the constant variable, but for immutable you can declare, and you must need to initialize within the constructor the immutable variable. Now the final thing about the immutable is if I try to create the string variable with immutable, so what it will do is it will give me an error. Error should be coming over here. Okay, you see, immutable variable cannot have non-value type. At this moment, immutable is implemented only for the value types like address, integers, and booleans, and these are the value data types. So at this moment, immutable is available only for value data types and not for the object data types like string and any other object. So it will be available later on, but at this moment, they are not available for the string and these type of variable cannot have non-value type. So you can create immutable variables, but for value types. So these are the difference between constant and immutable. Okay, any question? Functions we have already.
Is there any difference of usage of gas if you are initializing in something with a constant and without constant? Does it consume more gas, the stat variable?
Gas is actually being consumed while we do a transaction call. They are being initialized, so it is based on the cost of storage. So storage cost is based on the amount, the type or the value it is being stored inside this variable. So that's the storage cost. It is not the gas cost.
Okay, so there's no difference of any.
They are the constant variables. They are constant variable. Both of them are constant variable, and they are replaced actually wherever you use them. The actual values being replaced over there at the compile time. So at the runtime, it was like they are in place values. At the runtime, they behave like in place values. Okay, so the view and the view and pure function, we have also seen that view function is being, whenever you wanted to just read the state of a contract, then you use the view function, and if you do not have to even read the state of the contract, you use the pure function, and they do not consume the gas fees. But if a view function is being called in a function which is a transactional function, if a view function is being called inside a function which is a transaction functional, like if as we have seen, let's say this is a transactional function. This function actually initiates the transaction. If inside that function I try to call a function which is view, like this one, it is a view function. If I call this function, so this function will actually count in the gas fees. So the view function is, if it is being called inside a function which is a transaction function, then it will be included in the gas cost. Otherwise, if you call from the external world directly off chain, then they do not include the gas cost. That's the difference between from where you call the view and pure.
Will
Okay.
that cost be the fixed one?
Sorry.
Will that cost for the view function be the fixed? Because there's
It
no
depends.
computation or something.
It depends whether it has a computation or not. Because if you are calling a function which is just trying to return a value, then it does not have a much cost, but it still has an expression. So if your view function has 10 or 20 lines of code calculation, which actually does not change the state of a contract, but it actually has 10 or 20 lines of calculation. So if you're calling from the external world, then it will not be, there will be no gas cost. But if that function being called inside the transaction function, so all this statement expression will be included in the gas cost, so gas cost will increase.
Got it. Thank you.
Okay, so we have seen the default, because a default is being changed, as we have seen received and fallback function. Overloading, overriding, we have already seen. We need to see one difference related to them, which is inheriting a contract. Yes. Okay, so name, value storage 1, value storage 2. Okay. Okay, so we have a contract, and let me pick the values from here directly, so we don't have to worry about the implementation detail. Okay, so we have a contract called value storage. It has a one public value, which has the value of 2. And when we call the update function, which is actually a transaction function, it will update the value to 1. Now we have another contract. Value storage 1, and we'll inherit it from the value storage. So it will. Now, as we have seen that after Solidity 6, there are new keywords called virtual and override. So you cannot create a same method in the child class until you create it as a virtual or override. So what we need to do is we need to declare it virtual and make the child contract as override. And what I'll do is I'll make increment to 4. So this will update it from the to the 1. So if we call this one, it will make it 2 to 3. If we call this one, it will make from 1 to 2 to 6. And now we have another contract which is also inheriting from value storage. It does everything same, only increase it with, let's say, 8. Okay, at this moment all these things seems to be simple. Let's go for compile it. And okay, so now we have Okay, so instead of going value storage, let's go with value storage 1. And we'll do same for the second contract, value storage 2. Okay, so we have deployed 2 contract, value storage 1, value storage 2, and now I'll try to call. We have public property. Okay. Value storage 1 dot value now there is nothing special what we're trying to do at this moment. We are just trying to, we have created the value, deployed value storage 1, value storage 2, and when we call this update on the value storage 1, it will increase the value to 4. So before incrementing, it should be the 2, and after the call of update, it should be the 6. And then the script one next. Okay, so before it was 2, after an increment it is 6 as we normally expect, and if I change it to the storage 2, it's it's 2 and 10 because it adds the 8 inside it. Now what we can do is within the child contract, what we can do is we can call the same function of a parent class. So what and we can do it in 2 ways. One is where we normally know super dot update. Now what it will do is when we call this update value storage update from here, values plus 8, it will update the value to 10, and then when we call super dot update, it will also go over here and it will also increase the 1. So instead of 10, now it should be the 11. We can call the parent contract from the child contract, parent function from the child function. You see, it is 11. Now, another way we can do this is we say value storage dot update. So it is exactly like super dot update. There is no difference, but you can name the parent class. You see, so this is exactly same. There is no issue in it. And what we can do is we can call the parent function within the overridden function. If you wanted to call the function of parent, so we can call the super.update and value storage.update. Why it is important? For that, what we need to do is we need to understand one more thing, which is diamond problem. If you guys know about the C++ and the multiple inheritance, because Solidity has multiple inheritance, and the diamond problem previously, what Solidity has, it is now changed completely. So previously they say it is C3 linearization of the call of a function. These are being kind of eliminated. Why? Because as you have seen, you can also see that in these examples there is no virtual or override we call the when we override the functions, because before the Solidity 6 the override and virtual keyword was not there. Now if I come to over here, contract, value storage 3, inherit from value storage 1 comma value storage 2. Now what we need to understand is this value storage 3 is trying to inherit from two contracts, which is value storage 1 and value storage 2. Both has a similar function, update. Previously what, and if I do not give any implementation over here, previously it should work fine. Previously it was working fine and you do not have to provide any implementation. And when I try to call from here, like if I just trying to show you, let's say it is a value 3 and we call the update. So what was happening at that moment is, because the last inherited contract was value storage 2, so the function would call from the value storage 2, not from the value storage 1. So it was the C3 linearization which is coming from the Python, I guess. So that was the before Solidity 6, and that's why book is explaining based on this. Now when you inherit from two contracts and both contract has the same function, if it does not have, actually because value storage 1 is a separate contract, value storage 2 is a separate contract, then you do not have any problem. But if they are coming from the same hierarchy, parent is value storage and both are coming from the same hierarchy, value storage, and you're trying to inherit from a two contract which is coming from the same parent, so you have two function name update. So now what you need to do is you must need to override the function in your child contract which is coming from two contract. So you must need to override update inside the value storage 3. So you have to call function update complete implementation, so like this. Now the problem is you are trying to override two functions from function from the parent function. Parent function overrides it but does not allow child class to override again. For that we have to specify virtual. So if we want a contract child class to override a function, we want to make it a virtual. We will have to make it a virtual. From child class we need to specify the override keyword, and if child class also want its child class to also override that function, so child class also need to provide the virtual keyword. So now what we are saying, that virtual override, that means we are overriding the parent function and we are allowing child class to override that function as well. So for that we have to first, and this is all I'm explaining in the context of multiple inheritance from the same hierarchy. Now if you see, override is not working here, override was working fine. If this is the special case, exactly a special case, so do not bother about when you normally try to inherit from a contract, you use the virtual and keyword. This is a special case when you are actually stuck in a diamond problem. Diamond problem is you have a one parent that has a two child, and from those two child you are inheriting a single parent. So from single child you are inheriting for those two parents. That's the diamond problem. That's why it is completely special case. Now here what we need to do is we need to specify with override, we need to specify the name of a contracts which we are actually overriding. This is why books are not being updated, content is not being updated, because Solidity is getting changed so fast. Not everything is available directly when you try to implement. So the books are not getting updated, content as we have seen the Web3 material in W3C, it was also not getting updated because it is changing so fast. Okay, so now what we need to do is, now it will work fine. So first we have a contract value storage, which has a function update. Now the two separate contracts inheriting from this value storage, so it become they both become a child of a value storage. So at that point there is no problem, they will both override that function and it is fine. The problem occurs when you create a fourth class which is inheriting from those two child which is coming from single parent. Then we have a problem. So when we inherit them, first we have to make them virtual, then we must have to override. Previously it was not a problem, before Solidity 6 it was not a problem and the function would work. So if I, in the previous case, if I do voltage to value storage 1 at the end, so the function should work with from the value storage 1, but this is not applicable now, but you will see examples at many places like this. That's why I'm trying to explain you, which is called C3 linearization, and they have mentioned it over here in detail as well. C3 linearization. Okay, now you must have to override that function first. Second, you must have to specify the name of a contract. Even if you miss the one, it will give you errors that you need to specify the value storage 2 as well. That's how you implement it like this.
Here order matters. And we
Now
write,
order, now order does not matter,
thank you.
because we have our own implementation. So now order does not matter.
Sir, I have a question.
Yes, please.
Sir, in this case, if we use super keyword, so it will use which implementation of the parent? From the
Yes,
grandparent?
that's what I'm trying to coming all this point. So once I'll run this and then I'll show you.
Okay, sir. Another question. Sir,
Yes, yes.
you talk about this diamond problem where we have one grandparent, then two child, then again one grandchild. This thing can
Yes.
go like we can increase it as well. Like again, we have other contracts which are inheriting this last child, and this thing can go on the same loop.
Yes.
Okay.
It will go
Okay,
on. It will go on, and you can imagine whatever you wanted to do, and you can try to implement it.
Means there is no limit.
No.
Okay, sir. Thank you.
Okay, so now we have value storage 3. Okay, so now I want what I wanted to call the value storage, the update from value storage 3. Now the value storage 3 has a function which is trying to update the 10. So it has 2 already. It should be the 12. Right, we have 12. Now if I try to call super dot update, what it will do? It's 21. Now in 2 we have added 10, so it is 12. That means, okay, so there is also, well, so I have to comment this out because it's creating a cycle. So let's see the cycle. So once we added the 10 into the 2, it is 12. Then it calls the super dot update, it calls the value 8. So that means from 12 to it become 20. Then we call the value storage dot update, which is adding the 1. So that's why it become the 21. That's what we have seen here. So at this moment, let me just comment this out. So if I comment this out from the parent, it will be the 20. Now, if I wanted to call the update function of voltage storage 1, so what I can do is I can say, sorry, value storage 1. $16. You see, 2 plus 10, which is 12. And then we call value storage 1 dot update, which add the 4. So it becomes the 16. Now the sequence, if I remove it here and move this, like this, and call it again. See, it's still the 20. It is not calling the based on this sequence. So I have made the values 1. So the sequence does not matter in this override. So one thing I need to see, which I haven't myself seen this, if I do this now here, will it take effect or not? So it just came to my mind now. So let's see. Yes. So the what happened is we have inherited value storage 1 and value storage 2. So this C3 linearization has invalidated based on if you do not provide the implementation. But when you call the super dot update, then the sequence works. So the last one is value store. If value storage 2, then the super update will work for the value storage 2. If last one is value storage 1, then the super dot update will call the value storage 1, but it will still remains the confusing point. So that's why we have this contract name dot update. So we should always go for the value storage 1 dot update. So it will always be the consistent that what we wanted to call, which parent we wanted to call, it will go for that call. Okay, any question?
Yes, sir. So, as per my understanding, when we are using inside the override function, their sequence doesn't matter. But when we are inheriting them, that sequence matter. Whichever is on the right side, that will be preferred. And to
Yes.
avoid this, we should be using the name of the contract instead of super when we have multiple.
Yes, it's more convenient and more explicit. Maybe in future they just remove this as well. Maybe because if they have removed this implementation for that, you must have to provide the implementation. So they might try to give error over here. So we might see in future implementation that there must be an error because there are two contracts. So you need to specify which super you wanted to call. Maybe, but at this moment we have this feature, so we can use it.
Okay, sir. Thank you.
Okay, so this is done, I think. Custom reusable library. We have already seen the reusable libraries. One thing which is still calling of a base. Yes. So you see, when we in our inheritance, when we were working on inheritance from that article, so we have seen that if parent has a constructor which is accepting the parameters, so we have to create a constructor which should send the parameters to the parent constructor as well. So to call the parent constructor, we have two ways to call the parent constructor. From at the point of inheritance, let me just now you see we need to specify the constructor. So that what we can do is constructor that's the one way. Another way is what we can do instead of doing this. Can provide right at the inheritance time. So when we provide right at inheritance time, generally why you will do this, as we have seen, they have shown in this example. Generally, when we try to inherit from a contract, like we will be using for ERC 20 and ERC 721, we'll be mostly using the Open Zeppelin implementations. So when we inherit from that contract, they ask the constructor asks for the symbol and the name and the value for the token. So the symbol is a constant. Once you created it, it will always remain the same. And for you, it is not input coming from the outside. It is just the constant value. So what you can do is, let's say a parent class ask string symbol. What you can do is you can provide. Just provide like this. Let me try to compile it. So we know that at the time of implementation, either we pass it as a hard code string like this at the call of a constructor, or we can do it like this. So we don't have to worry about how we wanted to call it. So these are the two ways to call the base constructor. So we can call the base constructor at the time of constructor calling, and that will be mostly used when you in the child class you might receive value from then you pass this value to like this. Then it is not useful here. We just create the inheritance here. Then child class will receive value from outside world, which will be passed to the parent, and it will go over here. If we are not receiving from the outside world, so what we'll do, we'll just remove this and we'll provide the hard code value. So if we wanted to provide this hard code value, so we can use this here directly as well instead of providing here, because we are not getting it from the input from the outside world. So that's the two way of calling the base constructor when you have a parameterized constructor in a parent class. Any question? No. Okay, so we have seen the libraries as well in detail many times. We have seen. Okay, I think that's it. We have completed the chapter 3 as well, and we'll wind up over here. And as Sarja has already mentioned, that next class we will not be having a class. Next week we will not have a class because we all will be in Faisalabad. So see you after that week. Any questions? So we can wind up over here.
Yes, sir. Yes, sir. So actually, my question is related to the last class. So in last class, we talked about three things: call, delegate call, and static call. So I want to talk about its one utility that my question is related to that. So sometimes our contract size is like so much big, and we have problem to shrink it. And so at that case, because sometimes we are using interfaces, and there are so many functions which are some of them we are not even using, but we are inheriting the full interface. At that time, delegate call can be helpful because we don't use
it is most useful at that time. Generally what we do is if we wanted to use the another contract, so we have to import that contract inside our function like we do over here. We import over here. So when we import, that import become part of our contract.
Yes,
see
sir.
So what we can do is if we are not initializing that contract, if we are not using the new keyword, then the size will different, and if we are creating the new keyword, then size will different of your contract. So this contract called demo contract will have a different sizes. If you create the second contract will new, it will be the more bigger size, and if you use only, if you are using it as a reference and initialize, it is already created and you're just initializing it with the address, then size will be the lower. So it will the complete size of second contract will not be part of the call demo function. So generally when we wanted to create instance of a contract, then the delegate call and all those functions will be most useful for us to avoid those sizing problem.
Yes, sir. So and like those whenever some exploitation happens with big protocols, I think the hackers use these
delegate
things.
call.
Yes.
Delegate call is the culprit for most of the hacks. So you have to use it with very you have to be very careful while using them.
Right. Yes, sir. Sir, and like, sir, I belong to Faisalabad and I'm really excited. Like, you guys are coming here, and I really want to meet you. Thank you, sir.
Okay. Okay, guys. So we'll see week after next week. There'll be no class next week. Okay.
Yes. Okay, thank you.
I love you, sir.